Hello viewers, good morning. Myself is Venkatraman and my teammate Abhinav Pramadula is with me. Today we are going to discuss about the exploratory data analysis in R. What is exploratory data analysis? It is one of the first and foremost step which is going to be carried out in any kind of machine learning models building. So what is exploratory data analysis is going to tell about? It's going to tell about some insights, that is the meaningful insights about the data set which you have taken, which is going to be the main part which is going to the main part in any kind of machine learning building models. So why we are using EDA? If you want to check the summary of each of the attributes, that is the statistical summary like mean, median, mode, range, interquartile range, these are some of the statistical summary which can be acquired by doing EDA process. And in most of the times we cannot expect the structured data. There will be some missing values and the data will be unclean, so that it is a main part of any kind of machine learning model buildings is cleaning the data, that is imputing the missing values based upon the mean, median, mode. There are a lot of missing values imputation treatment are there, so that by doing the EDA we can check with the missing values in the data set. And the third thing is we can check the outliers in the data. The outliers are the extreme values. If there are a lot of extreme values in the data set present in the data set, it will definitely is going to be affect the prediction of my model. And the fourth one is we can check the correlation among the attributes, like how it is correlated, whether positively correlated or negatively correlated, or there is no correlation at all. So this kind of information can be gained from EDA. And the fifth one is the distribution of the data, the frequency distribution of the data. For each and every variable, we can find the frequency distribution by plotting the various statistical plots like box plot, histogram, pie chart, bar plot, and so on. So this is how it is going to be help me. In R, there are a lot of built-in functions which can be used to perform the ED analysis. But here we have tried some built customized R functions which can be improved the EDA process. We have built around 6 to 7 functions, which is going to help in reducing the time consuming in doing the EDA process using the built-in R functions. So with the first function, my teammate Abhinav will proceed.
The first function is function name is stats plot selected numerical variables 1, and we have defined as statistical plots for user defined variables. We have conducted two plots of box plot of index variable and histogram of index variable. Whereas in histogram we will find the frequency distribution of index variable. Why we are doing box plot is in order to detect the outliers are present in our data set or not.
Yes, what he's trying to say is this this is the library. EDA extension is the library. I mean, it's the package which you have created to improvise the EDA function, in which we have created a function called statplot selected numerical variable. That is the main objective of this function is plotting the statistical plots for user defined numeric variables. So here there are three parameters which I am going to input into this function. The first one is the dataset. Here we have taken Boston, and then the second one is n number of variables which I am interested to study about the frequency distribution. Here I have taken 1, 2, 3, and the third parameter is a folder where I have to expect where I am expecting this function to export the plots to be exported. So this is the folder which I have passed as the third parameter. So this is the flowchart how my stat plot selected numerical variable underscore 1 is going to be function. If there is no folder which I have passed as the third parameter of this function is not present, so that my function will create a new folder, and then it will take the data set, and then it will check the data type of the user variable. If it is numeric, if it is not numeric, then my function is going to print as the variable is categorical. If it is numeric, then again my function will check whether the length of unique values is greater than 5% or not. If it is not, then my function is going to print the variable is categorical. If the length of unique values is greater than 5%, then this function is going to plot the histogram and box plot side by side as we are seeing here, and then it is these plots are going to be exported into the folder which you have passed as the third parameter. So this is the first function, and the second function is statistical plot for all the numeric variables. In the first function, the user is going to define which are all the variables they need the plots. But the second function is going to plot the plots, I mean the histogram and box plot for all the variables if it is numeric. So my function is going to check all the variables, all the variable data type. If it is numeric, then histogram and box plot for all the numeric variables is going to be plotted, and those plots are going to be exported into the folder which I have passed as the third parameter for this function. If my variable is not numeric, that is categorical, then my function is going to print as the variable is categorical. This so my second function is going to work. And then the third function is chat plot all numerics come categorical. If I have a data set which contains a mix of numeric and categorical variable, for numerical variable we can plot box plot and histogram, and for categorical variable we can plot bar plot and pie chart in order to study the frequency distribution. So this function is going to help to plot the histogram and box plots if it is purely numeric, and if it is categorical, then my function is going to print the variable is categorical, as well as it's going to be plot the pie charts and bar plots of that particular category variable. So so my function is going to be help here. So let's see about the next function. It's a function stat plots aggregate images. If I have passed three variables as my input from the data set Boston, and my third parameter of this function is going to be explode all the histogram, box plot and pie chart and bar plot into the folder which I passed as the third parameter. And what is this fourth parameter? If I want all the PNG files aggregated in a separate folder, so that my fourth parameter of this function is going to export all the PNG files from the folder which I have passed as the third parameter, going to be exported into the folder which I have passed as the fourth parameter. So this is how my function is going to be help here. Let's see a demo here. So this is my data set, and this is my interest of variables which I have to study the frequency distribution of the variables. And the It's a folder where my function is going to export all the PNG files in default. And fourth parameter is a parameter where I want all my PNG files should be exported or aggregated into a separate folder. Now let's see how my function is going to work here. Here the plots has been exported into the folder images 2, and those PNG files, all the PNG files has been exported to the folder images 3, which I have passed as a fourth parameter in this function. Let's see. Yes, it's working fine. So this is how this function is going to help me. Now let's look at the next function, outlier detection. As we see earlier in the EDA process, in most of the times there might be possible for extreme values to be present in the data set, which might impact on the prediction of my machine learning model. So that if I want to study about the outliers in each and every variable of my data set, and if I want the summary of how many variables are there in each and every variable in the below the lower bound and above the upper bound, so that this function outlier without data transformation is going to help me in giving the summary of number of counts of outliers in the below the lower boundary and number of counts of outliers above the upper boundary, and whether the outlier has been detected for that particular variable or not. See, for the first function, so for the first variable, outlier has been detected because in the upper bound there are 66 outliers are present. In contrast to the first variable, for the third variable there is no outlier has been detected. Below the lower boundary there is no outlier, and above the upper boundary there is no outlier. So this is how my function. This function is going to be helping. And this is another function which you have created is outlier after log transformation. So this is an extension of the previous function. Sometimes it would be necessary to transform the data while doing machine learning model building, so that if I want to study the outlier distribution before the data transformation and after data transformation, like here I have taken log transformation, so here I can get the summary of outliers before the data transformation and summary of outliers after the data transformation. So this is how this function is going to be help me. If it is numeric variable, then the summary is going to be printed, and if my variable is going to be categorical, then those variables will be printed as the categorical variable. This is how my function. This function is going to be help me. Now let's look at the next function, the missing values percentage. As we said, there will be more possibility for missing values, so that data cleaning is required. So if I want to study about the distribution of missing values in my data set for each and every attribute in my data set, so that this function percentage missing values function, this is a customized function which you have built under the package EDA extension, which is going to be print about the summary of number of missing values in each and every variable and percentage of missing values in each and every variable. So this is how this function is going to help me. And the last function is hypothesis testing to check dependency of variables. So this is the flow chart, how this function is going to be help me. Once the data has been input, this function will check the data type for all the variables. If it is non-numeric, then it will do the chi-square test and print the p-values of a data frame. And if it is numeric, then again my function will check whether the length of unique values is greater than 5% or not. If it is not, then it will do my function will do the chi-square test and print the p-values as a data frame. If the length of unique values is greater than 5%, then my function will consider it as a numeric variable and do the t-test and print the p-values as a data frame. So this would be the output. Here, this image is showing, like, I have separated the categorical variable from the dataset and separated the numerical variable from the dataset. Then it will be easier for my function to distinguish the numeric and categorical variable to perform whether chi-square test or t-test. So this is how this function is going to work, so that finally I will get a data frame like summary of the p-values. So this is how this look like. So what is the advantages here? If I have a summary like data frame of the p-value, so that it will be easy for me to compute the statistical significance of dependency of the variable towards the target variable, so that it will definitely is going to be help here. So this is how we have worked. We have built around 8 functions: 1, 2, 3, 4, 5, 6, 7, 8. So we have built 8 functions. So we hope these functions are really going to help for reducing the time consuming in doing the EDA process. So we believe this video is going to be helpful. If any questions, you can ask. Thanks for viewing.
Thanks for viewing.
Thank you. Bye.